Hello everyone, my name is Shivpujam Gautam and today I am going to explain you about the IoT internship and giving review about that. The teacher who had explained us was very good in nature and also very uh, courteous. She explained each and everything about the devices we used used during the whole internship period. In this internship, we had made a smart warehouse monitoring system using various sensors and Arduino for processing. We also used Thingsboard IoT cloud for our cloud purposes and sharing information between devices and for using internet we had used public subscriber model using MQTT protocol called message queuing telemetry transport protocols. We had used DHT22 sensor for humidity sensing, LM35 for temperature sensing of the warehouse, and we also have machine error sensors, and we also used some um, some of the vibration sensors to calculate the environment of the warehouse where we keep our products to be safe. We had made this smart factory monitoring system or a smart warehouse monitoring system in two parts, node 1 and node 2, because it was so big, or the code was very lengthy to write. So in first node we had used DHT22 and LM35 sensors and Arduino processor to process the information, and for node 2 we had used vibration sensors and door sensors and light sensors so that we can manage overall warehouse environment to be safe for the products we use. Now I am going to give you some explanation using the PPTs given by the Emertxe, and also at the last I am going to show you the whole node 1 and node 2 devices which I used to make the whole project during the internship period. Okay. Here the presentations I was talking about are here. First we are going to discuss the topics we had studied far in the internship during our 15 days long time. So these are the topics. In first day we had covered about the project or its introduction, what is its architecture and its requirement. We also saw a demo about it, and we had also understood what IoT is, because some of the students do not have information about IoT or IoT components. So that was our first day with the introduction, and second day was our demo where we got a demo about node 1 and node 2 and how our project will work at the end. In third day we studied about the Arduino basics and Picsim lab, how to set up the Arduino IDE and Picsim lab so that we can work freely during our internship period. So here we configured the Picsim lab and Arduino IDE. LED we tested with LED programs, and digital input output operations we took to understand. Here we checked the Picsim lab environment by blink LED turning. Then moving forward to the day 4, we had studied about the analog sensors and data acquisition, We have used analog read and write function to take input from the sensors and convert it into the digital values where the processor can process it and we can show it on the dashboard. So here, so by doing these we had displayed the values of potentiometer and celia in monitor by converting the values from analog to digital. Then we also have done some assignment works during that period. At day 5 we had used a DHT22 sensor and known about it very well, about its libraries, and used it in Picsim lab for simulation and read temperature and humidity data we had gained by using the HT22. We displayed it in the virtual terminal and for every 2 seconds, and we also handled some error during that implementation. Then during the meantime, we studied about the Ethernet shield and W5100 chip specifications. Ethernet shield is used to connect Arduino with the internet because, as you know, Arduino is not IT device. Then in day 6 we studied about MQTT protocol called message queuing telemetry transport and pub sub client. Then at day 7 we set up our cloud platform called Thingsboard and known some features of it, how we can set up our device in cloud and transfer information from our device to the cloud and then cloud to the device receiving and transmitting that information. Then day 8 we studied the node 1 completely, where we used the DHT22 sensor and potential. So at day 8 we had studied the node 1 and used sensors like DHT22, potentiometer and buttons to configure the node 1, and the name of the node 1 is production line. And at day 9 we had uh, made node 2 for like warehouse monitor implementation. In node 2 we had HT22 for humidity sensing, PIR sensing, and door sensor for closing and opening door, and light sensor LDR to check if light was efficient or not in the warehouse. At 10 day, we made the dashboard and visualized the whole system we had made in Picsim Lab, and at day 11, we automated our alerts and warnings given to the through the system cloud to the system. And 12 and 13th day was for testing and RPC implementation. So here is the schedule. Now I am going to explain you the requirements of the products, the devices, and the hmm, things we had used our project. Things are like what is the scope of our project. First, first of all is that the real-time sensing about the environment of the warehouse and sensing the temperature, humidity, light, and etc. of the warehouse, and automated actuation. Secondly, where we automated the uh, messages about the warehouses, and we also control the temperature of the warehouse remotely via things code or remote control devices, and visualized the live at the dashboard all the information about uh, environment of the warehouse using dashboard of things board. And we have alarm systems for the times when something changes for the sensors, and any situation comes up. Here are some definitions or devices and abbreviations we used during the product. IoT, you know that IoT means Internet of Things. Network physical devices that collect and exchange data. Sensors send data to the cloud, and cloud processes the data and gives it to the receiver or the person who wants to see the information about something or place, some place. MQTT is messaging queue telemetry transport. It is a lightweight publish subscribe messaging protocol used in IoT, where we can send SMS remotely from the cloud based application to the person. And ThingsBoard is a cloud IoT platform we are using. So, as a subscriber or a broker in our project for visualization also, and data collection and processing. Here we made node 1 and node 2. Node 1 is production line for, and node 2 is warehouse environment. HT22 here you can see that digital temperature. T sensor LM35 is the temperature sensor. PIR is passive infrared motion sensor for closing and opening of the door, and LDR is light sensor where we analyze the light of the warehouse. And W5100 is a Ethernet controller IC where which is used for connecting the Arduino with the internet, so we can transmit and receive information through cloud. And DC is analog to digital converter, because some sensors gives us analog values, so we have to convert it into digital values. So the Arduino microprocessor has have to process it, or the Atmega microprocessor can process it efficiently. Pixim Lab we used for simulation of the whole device. Here are the use cases: real-time production line monitoring, automated warehouse ventilations, and remote equipment shutdown, security access monitoring, sensor fault handling. These are the tasks we had completed for node 1, and for node 2. These are the non-functional requirements. Here is the data flow. Our system is working like a flow that firstly simulated sensors generate signals for the temperature, humidity, vibration, motion, light, and door opening closings for, in equal intervals. And these are virtual components, by the way. Then sensor manager processes the analog to digital values, because analog sensor analog values are converted into digital values and converted into decimal units. Then telemetry manager serializes all the keys into compact JSON string, because Things both can process data in JSON format. Network manager publishes the JSON to MQTT topic. It Network manager publishes the data because MQTT uses a publisher subscriber model. So where the data is published, then things board receives the message, which is working as a broker. It stores value and evaluates the rule chain conditions. Then dashboard widget auto refreshes from the server without browser reload. Here the values are coming real time. So the values are auto-refreshed. Alarm conditions create entries and alarm table visibly operators. Okay, these is the data flow. Here the public subscriber model is used where publisher publishes information and broker saves it and processes it. Then subscriber subscribes to the topic and gets information by the from the broker. Then these are the pin assignment to the Arduino pin. This is for node 2 component specification. These are the components we really used. Microcontroller. We are used at Mega 328P and Ethernet shield for connecting Arduino to the internet. And temperature humidity sensor the T22 and for precise temperature LM35 potentiometer for vibration inputs, motion sensor and PIR sensor for door sensing and read switch and for light sensing LDR we have used and relay module LED D and module and the architectural work is maintained by these modules like config.h sensor manager actuator manager telemetry manager and these are all software handlers of the program or the system flowing between the devices. These are the telemetry keys. Okay. These are all the information about our project. Now I am going to show you the program we had written for node 1 and node 2. भाई तो सिर्फ मल्टीप्लाई कर तू वन में क्या मल्टीप्लाई करेंगे तुम फोर बन जाए भाई वन में मैं फोर ही मल्टीप्लाई करूंगा तभी तो फोर लगेगा तो मतलब जहाँ पे ऑक्सीजन होगा तो कहाँ पे लेफ्ट हैंड साइड में ये में क्या मल्टीप्लाई करूँ ये this is the preferred actually libraries are not working in my laptop. You can see that. So I cannot run the program in this laptop, but I have tried in other computers, so you can understand that. Now for node 2, here we also had a creator program. This is for actuator. This is for configuration. It's for telemetry process. This is for sensor manager. And अब ऑक्सीजन जो है इधर 4 हो गया और इधर भी this is for network. टोटल कितनी लेफ्ट है मैं फिर से क्लिक लिख if I am going to explain the whole program, it will be very lengthy. So I am not explaining the program. Here is the program for Node 2. We had copied from the Node 1. The whole process is same regarding different sensors. So this is the program. Here I also had some programs written for different sensors. It is for DHT2. You can see that it is half one. I have tried to make it full. Here is for things bone. Now I'm going to show you the setup we had made or the whole system or the dashboard we had made during the internship. Here is the final results. Yeah, this is the Picsim Lab application we had opened, and this is Arduino Uno. Once I have to smaller my screen for recording. This is the Node 1 Arduino Uno. Here, the devices used for connection are these. Let's see. This is LM35 for accurate temperature measurement. This is DHT22 for humidity. We can also change it. Here, temperature, we can change it. This is virtual terminal or information comes in it. As you can see that some information is regularly coming here. Digital value in digital values, by the way. These are LED indicators. This is a push button for machine control, and this is W5500 in Ethernet controller, which is used to connect my controller with the internet. And this is for the Node 1, by the way. This is Node 1 Arduino. This is Node 2 Arduino. Here, spare parts used higher. These ये भी स्टेट है क्या ये स्टेट मतलब इनकी अवस्था तो हम स्टेट को बेटा ब्रैकेट में सॉलिड के लिए ऐसे लिख देते हैं लिक्विड के लिए ऐसे लिख देते हैं और गैस के लिए गैस और एक और होता है एक्वस सॉल्यूशन क्या होता है के लिए और सॉल्यूशन को हम बोलते हैं लिखते हैं इस
ये प्योर सॉलिड है, प्योर लिक्विड है, और एमपी3 कोको क्या रहेगा? नहीं, सॉलिड रहेगा ना। ये बेसिकली ये पता क्या है, ये जंग लगी है। आयरन में जब पानी बार बार मिलता है तो वो क्या बनाता है? जंग। बस क्या ही होगा? होगा। बस में और रक्त कैसा होता है? लिक्विड होता है क्या? सॉलिड होता है। ये भी क्या है? सॉलिड है। और हाइड्रोजन क्या लिक्विड है? इसमें आप देखेंगे, ये हो गया सर स्टेट। क्या लिखना हो गया? To make a chemical equation more accommodative to physical state of the reaction for the mentioned technical. As you can see that all the components in node 2 we had used same components, only some are changed. DFT to tell humidity is a virtual terminal. We had used this switch for door switch, door opening and closing, remotely controlling. This is a light sensor for light in warehouse. This is used for indicating the vibrations, and this is W55 Ethernet controller. These buttons are also used for checking information. And here we can see that this is our things board application for the cloud application where we are visualizing our system's information. This is production monitor, IR device dashboard. These are the information, temperature, humidity. Actually, this can be changed. I had made a mistake. It is humidity. It is time series chart. See devices. There are devices, warehouse monitor, warehouse test, production line test. Okay, that's how your dashboard will look. We also have some information about devices with token is given, which you can enter and connect to the devices like Arduino, Arduino IDE. That's a which is provided by Things for this is a full dashboard. You can add dashboard for names also. Create new dashboard where you give it the title, description, and you can upload some image if you want. For adding your devices, you can you can also include devices. Select name, label it, and upload it. Okay, this is the final output. You can see that it is. Thank you.